Greetings, math fans. All right, so today we're going to do is tangent sum and difference. Okay, and we're kind of basing it off of our knowledge of tangent is equal to sine over cosine. All right, so let's start out with tangent of A plus B. Would you guys agree that's equal to sine of A plus B over cosine of A plus B? Sweet. Okay, and so knowing sine of A plus B is sine of A cosine of B, same sign, so plus cosine A sine of B divided by cosine A cosine B, opposite sign, minus sine A sine of B. Sweet. Okay, so here's the deal. I want to kind of get things in terms of tangent. Everything's in terms of sine and cosine. So the way to get things in terms of sine or tangent is to multiply the top by 1 over cosine of A cosine of B, the bottom by 1 over cosine of A cosine of B. That's going to give us lots of tangents. So, because of course multiplying it by, that's obviously 1, right? So if I multiply all that out, right, kind of small here, but it's going to be sine of A cosine of B. I'm just kind of distributing that now, over cosine A cosine of B plus cosine of A sine of B over cosine A cosine of B divided by, it's looking a little nasty, but it's okay, cosine of A cosine of B over cosine of A cosine of B, and then minus sine of A sine of B over cosine of A cosine of B. Okay, so let's simplify a few things here. First of all, the cosine of B's cancel. Second one, the cosine of A's cancel. The next one, cosine of A's and cosine of B's cancel, so I just get 1. And the fourth one, nothing cancels. So I wind up having, if you look at it, what's sine of A over cosine of A? Isn't that tangent of A? And plus sine of B over cosine of B, isn't that tangent of B? And underneath I have 1 minus, well, it's sine of A over cosine of A, sine of B over cosine of B, so isn't it just tangent of A, tangent of B? Hey, hey, look at that, man. It's all in terms of tangents. So this is tangent of A plus B. Okay? Got to know that. That's important. Let's really quickly do tangent of A minus B. Well, how do you think we're going to do that? Just like we did with sine and cosine, we substitute tangent of A, right, it's going to be plus a negative B, right? Guys agree with that? Okay, so we're going to put a negative B wherever we see that, so let me just write that out. It's going to be tangent of A plus tangent of negative B over 1 minus tangent of A tangent of negative B. And so I can write out then my final answer, tangent of A minus B. Knowing our negative angle identities, we have tangent of A, and tangent of negative B is the same thing as negative tangent of B, so it's minus tangent of B. And on the bottom is 1, and that becomes plus, right? Because tangent of negative B is negative tangent of B, so 1 plus tangent of A tangent of B. And that's your other difference for tangent. So how do you remember this? I always give you guys little weird ways to remember things, but this is a negative here, and the negative's there, so that matches. and this one's positive, and this one's positive here. Okay, and then the bottom is the opposite. Okay, but also here this matches up tangent of A, tangent of A. So it's tangent of A and then tangent of B, and the bottom is 1 plus or minus tangent of A, tangent of B. Okay, got to know those. Really, really important. Okay, so let's start out with a nice little friendly example. I have these kind of handy. I don't have room to keep it on there, but let's do it. All right, so we have, let's start out with our traditional tangent of 15 degrees. Beautiful. So that's the same thing as tangent of 45 minus 30. Okay. So here's a thought for you. Remember, you can use any combination you want, 45, 30, or 60 or 45, right? Well, think about when I actually plug it in, I'm going to have a fraction using that fraction I just came up with. Do you guys agree if I do tangent of 30, I'm going to get root 3 over 3? That's a little nastier because now you have a fraction and a fraction. So here's my thought. Why don't we just do this? Tangent of 60 minus 45. You're going to get the same answer, but this was already a little bit easier because what's the tangent of 60? Root 3. You don't have another fraction to deal with. And of course, tangent of 45 is just 1. Okay? So I'm going to go this route here. And of course, this being my A and this being my B. Okay, so we're going to get tangent of 60 minus, because same sign, tangent of 45 over 1 plus, opposite sign, right? Tangent of 60, tangent of 45. Okay, so just, it's got some radicals you got to deal with here. So we're going to do tangent of 60, which is root 3, which is a lot nicer than root 3 over 3, minus 1 over 1 plus tangent of 60, root 3, times 1. So that just gives us root 3 minus 1 over 1 plus root 3. No radicals in the denominator, so you got to rationalize it. You're going to multiply by its conjugate. So it's 1 minus root 3 over 1 minus root 3. Okay, and that gives us, on top we FOIL it, so we get root 3 minus 3 minus 1 plus root 3. All over 1, and the inside and outside cancel, and last gives us minus 3. So we get 2 root 3 minus 4 over negative 2. Of course, you simplify that, and so you wind up getting negative root 3 plus 2. Okay? Really pretty easy. And, you can plug that in and check in your calculator, too, and type in tangent of 15 and then type in that value, and you will get exactly the same thing. All right, so let's keep going. It's almost tradition, right? I'm doing an example with sine, sum and difference, cosine, sum and difference, and tangent. So let's do tangent of 5 pi over 12. Once again, get your combinations. So pi over 6, pi over 4, and pi over 3. So pi over 6 is 2 pi over 12. Pi over 4 is 3 pi over 12. And pi over 3 is 4 pi over 12. Okay, so tangent of 5 pi over 12 is going to be tangent of pi over 6 plus pi over 4. Sweet. All right, so let's get our values here. We're going to do tangent of pi over 6, same sign, plus tangent of pi over 4, divided by 1 opposite sign, minus tangent of pi over 6, tangent of pi over 4. Beauty of this is whenever you use tangent, you're probably going to be using pi over 4 to get a combination. You're never going to be using a 30 degree and a 60 degree angle because it doesn't make sense, because nothing unusual about that. You're using that 45 degree angle to give you that 15 degree odd angle. Okay, so and the nice thing about tangent of pi over 4 is just 1. All right, so we get tangent of pi over 6. We're going to get root 3 over 3 plus 1 over 1 minus root 3 over 3 times 1, right? I'm just going to leave it like that. Okay, so before we rationalize, guys, let's get rid of the fraction. Okay, it's brutal to have a complex fraction. So we're going to multiply the top and the bottom by 3 over 3. What that does, it gives you root 3 plus 3 over 3 minus root 3. Okay, looks pretty reasonable. And now we rationalize it. So we're going to multiply by 3 plus root 3 over 3 plus root 3. So that's going to give us 3 root 3 plus 3 outer, inner plus 9, and last plus 3 root 3. In the bottom we're going to get 9, outside inside cancel, minus 3. So we put it all together and we get 6 root 3 plus 12 over 6. Okay, and then we simplify that and we just get root 3 plus 2. That's our answer. Pretty easy, pretty easy. Okay, so let's keep going here with another example. Tangent of negative 255 degrees. Brutal, brutal. But remember, tangent of a negative angle is negative tangent of that angle. So, you know, that's kind of nice. The only thing you have to worry about is that negative right there, math fans. Don't forget that negative. Okay? All right, so let's just ignore the negative for now. Tangent 255. Remember, you got a couple steps here. First step is 255 is in this quadrant here. What is tangent? It's positive. All right? And then you got to get a reference angle, so we're going to subtract 180 from that. We're going to get 75 degrees. So our new problem is positive of tangent of 75 degrees, but don't forget this negative. It's almost like you got to worry about a couple negatives here, so you got to throw that in front, right? Truly, we could have done a little bit different way. I could have just added 360 to that 255, and that would have been okay. That would have given us 105 degrees, and then we deal with 105 degrees. And think about that. If I would have added that, if I would have added 360 just due to coterminal, I would have tangent of 105. And what's a reference angle? 180 minus 105, which is 75. That's a reference angle, which is what we have for our problem. And where's tangent of 105? It's over here, so it's negative. So we've got this exact same thing, negative tangent of 75. Okay? All right, so let's do that one. That's equal to negative tangent of 30 plus 45. So we're going to do, and don't forget, let's keep that negative on the outside, right? But it's going to be tangent of 30 plus tangent of 45 over 1 minus opposite sign, tangent of 30, tangent of 45. Okay, so let's keep moving down here a little bit. And so we have negative tangent of 30 is root 3 over 3, 3's rule, plus 1 over 1 minus root 3 over 3. Okay, and let's rationalize. So get rid of the fraction. So we're going to multiply this by 3 over 3, right? And that's equal to, keep that negative on the outside, so it's root 3 plus 3 over 3 minus root 3. Okay, and rationalize now. So we're going to do 3 plus root 3 over 3 plus root 3. So keeping the negative on the outside again, I'm going to get 3 root 3. So first outer plus 3, inner plus 9, and last plus 3 root 3. On the bottom, we get 9, inside outside cancel, minus 3. So we get negative, and this is going to be 6 root 3 plus 12 over 6. So move it down a little bit again. That's going to be negative, and then it's going to be root 3 plus 2. So my final answer is negative root 3 minus 2. Okay? You know, it's a little bit of work, but it's really not that bad. Of course, we have our traditional working backwards problem. working backwards, meaning I'm going to give you kind of a nasty function. You need to recognize that it is tangent, sum, or difference, and then find either a single trig function or a single value, depending on what I'm asking for here, okay? So let's start out tangent of 44 degrees plus tangent of 1 degree. Brutal! 1 minus, over 1 minus tangent of 44. Tangent of 1. So totally recognize that this is a tangent of A plus B, right? Because you got a plus sign here, and that's your A and that's your B. So it's tangent of A plus B. So it's tangent of 45, which is equal to uno, or 1. All right, that's pretty easy. And let's do a nice friendly triangle problem here. So we need a lot of room for this one. So given cosine of S equals 2/5, and we're in quadrant 4, and sine of T is equal to -1/2, and we're in quadrant 3. I want you to find sine of S plus T, cosine of S plus T, and tangent of S plus T. All a little review. Very, very good. All right. So, of course, the first thing you're going to do is you're going to draw your picture. We're in quadrant 4. Okay, and this is going to be 2 and 5. And then using Pythagorean theorem, we're going to get negative root 21. Don't forget the positives and negatives. Those are huge, huge, huge. And then quadrant 3 was over here. And this is -1 and 2 y over r. And then, of course, Pythagorean theorem, this is going to be negative root 3. All right, so let's come up with, we've got cosine of S, so we're going to do sine of S is equal to negative root 21 over 5. And tangent of S is equal to negative root 21 over 2. The ox, okay? Sine of T is -1/2, so we're going to do cosine of T, which is going to equal negative root 3 over 2, and tangent of T is equal to -1 over negative root 3, which rationalized is, well, it's 1 over root 3. You guys agree with that? And I definitely, well, let's see how it's rationalized. We got root 3 over 3. Okay, pretty easy. So let's put it all together now, finding S, sine of S plus T. So sine of S plus T, and hopefully you guys remember, well, let's just write it out. Sine of S, cosine of T, same sign, plus cosine of S, sine of T. It's not a bad idea to write it out, because then when you plug it in, it's actually easy just to substitute it in. So sine of S, negative root 21 over 5, and cosine of T, which is negative root 3 over 2, and plus cosine of S, which is given on top there, 2/5, and sine of T, which is given on top there, which is -1/2. Okay? The only issue, I have negative root 21 times negative root 3, and you guys should understand there's a 3 that's common with both of them, so I can pull 3 out, and I wind up getting 3 root 7, right? And then this is just minus 2 over 10. Pretty easy. Cosine of S plus T equals cosine of S, cosine of T, opposite sign minus sine of S, sine of T. All right, so that equals cosine of S, which is 2/5, cosine of T, which is negative root 3 over 2, and minus sine of s, which is negative root 21 over 5, and sine of t, which is negative 1/2. Okay, I need to move this down a little bit here. If I multiply that together, I get negative 2 root 3, and that's 3 negatives, so it's minus root 21 over 10. Okay, so that's that guy. And then we have tangent of s plus t. Alright, so it's, I'll write that one out also, tangent of s plus, same sign, tangent of t over 1 minus opposite sign, tangent of s, tangent of t. So, I mean, you guys, we have everything up here, right? So, right, I can't quite fit it. Oh, I can't fit it in. Okay. So I have tangent of s, which is negative root 21 over 2, plus tangent of t, which is root 3 over 3, divided by 1 minus negative root 21 over 2 times root 3 over 3. Okay, doesn't look too bad so far. Let's simplify that bottom a little bit here. So it's negative root 21 over 2 plus root 3 over 3, and that's 1, and then it's going to be 1 plus, right? And let's say, like I said, simplify that, so we're going to get, we can pull a 3 out, so it's 1 plus 3 root 7 over 6. You guys good with that? And let's get rid of the fractions. So we're going to multiply the top and the bottom by 6 over 6. So that gives us negative 3 root 21 plus 2 root 3 over 6 plus 3 root 7. Okay? And then I'm going to rationalize this by multiplying it by 6 minus 3 root 7. Got to do what you got to do, right? So the first term is going to be, let's move this down a little bit more, negative 18 root 21. So first outer gives us plus 9, but I can take a 7 out of there. You guys agree with that? So 9, so plus 63 root 3. I hope you guys see that, because I have 3 times 3 is 9. And then 7 times 21, I can take a 7 out of there. So 7 times 9 is 63, and I have a 3 left over. Okay, and then inside is plus 12 root 3. And last is minus 6 root 21. All over 36. As you can see, tangent's the hardest one, right? Inside, outside, cancel. And then that's going to be minus 9 times 7, so minus 63. All right? And if I simplify that, I get negative 18 root 21 minus 6 root 21 is negative 24 root 21. And 63 plus 12 is 75, so plus 75 root 3, all over 36 minus 63 is negative 27. All right, and I don't like that negative in there, and I'm kind of running out of room, so I can get rid of the negative on the bottom, and I just have 24 root 21 minus 75 root 3 over 27. Okay, I could actually simplify it a little bit, because what goes into all of those terms? Doesn't a 3 go into all those terms? So I can actually simplify that one to be 8 root 21. You guys are going, what? More stuff? Minus 25 root 3 over 9. That is actually my final answer. There might be a yox over in this corner here, but here, so I'll write the answer out. So it's 8 root 21 minus 25 root 3 over 9. That's your final answer. Okay? Not too bad, right? I mean, it's a little complicated. Well, here's another thought, math fans. We use that fancy tangent equation, but let's think about this. If I can have a little more room here. Don't you guys agree that tangent, I can write this in red so we can see it in here. Don't you guys agree tangent of s plus t equals sine of s plus t over cosine of s plus t? Isn't that how I originally actually came up with the formula? So here's the deal. If I'm just asking you for a tangent of s plus t, you got to kind of do a little bit of work. But if I'm already asking you for sine of s plus t and cosine of s plus t, can't I just substitute sine over cosine? So here's sine and here's cosine. So it almost makes it kind of nice, because what I could have done is if I do this value over this value, so let me just draw that over that, don't the 10's cancel? Or you can multiply by 10 over 10 and they cancel. And you wind up getting 3 root 7 minus 2, 3 root 7 minus 2 over negative 2 root 3 minus root 21. So you could work from there and rationalize. Okay? You multiply obviously by negative 2 root 3 plus root 21 over the same thing, and you rationalize it. So which one's easier? I think if you have to calculate this, why not just use those values? If you don't have to calculate it, you got to use tangent of s plus t to get your answer. Okay? Either one's going to give you the same answer, but one's easier one way and one's easier the other way. So it's your choice. All right. Anyway, that's tangent of sum and difference. Hope you guys are good to go with all three trig functions now, both tangent or all three: tangent, sine, and cosine. All right. That's it, math fans. Have an outstanding day. Adios. Goodbye.